Hello, welcome to the 6th Gitaly training video where we look at how Gitaly fits into the rest of GitLab. Last week we looked at the fetch source branch RPC and how Gitaly internally replicates Git data between forks to make it possible to have merge requests across forks. Today I want to look at what happens in a merge request and specifically at how Gitaly creates commits on behalf of a user, and also how Gitaly sort of fakes doing a git push to itself. So to look at the git push aspect, I came up with a little demonstration to show what's happening. Maybe the first thing to show is that the hooks actually run when I edit a file. Before I try to show that, let's try editing a file to make sure that all that is working. So this is GTK running in on my local machine in GitLab Enterprise Edition. So hit the edit button. The edit button is also an example of the GitLab creating a commit on behalf of the user. So maybe the merges themselves are not that different from how the edit button works. So maybe we just end up looking at this button. Most of it works the same. So I've edited the file. I'm going to commit the changes. That works. Does it? Yes. So my claim is this is a proper git push that runs hooks and everything. One way to see that is to look at the activity feed of the project. Which takes a moment, and to filter down to push events. And this is my commit just now. So when I'm playing with this stuff, I like to verify. So pushes work via git hooks. And right now, the nice thing about the git hooks is, well, what's nice for debugging is that they're written in Ruby. So they're easy to modify and get in the middle of if you want to understand how things work. What's slightly difficult now is finding the right pre-receive hook, because if I go to my GDK root and I look for the pre-receive hook, then I'm going to find more than one. Whoa. Okay, that's me running the wrong find command. Okay, now as a fun aside, this is a bug in or a shortcoming of my terminal that I get really interrupted when it's doing that. So I just have to open a new terminal window. Find.-name pre-receive. That should produce less output. So we can ignore this. This is only used for testing in GitLab. And but okay, so there's one in GitLab shell. That's where the repo that used to contain the hooks, and we're in the middle of migrating them to Gitaly. Then this is where I would normally be editing Gitaly source code and running tests. But this is GTK, and when you're running GTK in development mode, it runs a quasi-isolated copy of Gitaly that is in the gitaly/assembly directory. So these are actually the files that I care about. I just told you that we're moving these hooks, so you can see that the actual hook is still in a vendor subdirectory of Gitaly. And this thing is just a shim that launches that thing. So this thing does a directory name resolution and uses a relative path to go to that other file. So I think this is the hook file I want to open to do fun stuff, and I already have it open here. If I want to be sure, I just make it fail, because if the pre-receive fails, then you get a message that yells at you. This is the hook you are looking for. A board will print the message and exit with status 1. So now if I edit the file, let's see if I can reuse this edit page. The back button, I think I can. This should now fail. Yes. So I found the right file. Now, the thing I wanted to show is that is how this compares to a normal push. And one of the things that I maybe haven't shown yet or not in much detail is how these hooks get invoked. So I made some edits to my local Gitaly, where I have the Gitaly executable populate this environment variable with the process ID of the currently running Gitaly process. And I wrote some code in this hook that, well, let's get rid of this thing, that will use PS3 to look at what is the process tree running under that process at the moment the hook runs. So if I activate this, if I uncomment this code and I run this now, then, and let's just truncate that file. And tail that file. So now this window is going to tail this hooks file. So that's working. And here we have the process tree of what happened when we reach that point in the hook. And you can see that here at as the top process, we have Gitaly. And then underneath that, we have two gitaly-ruby processes. And then one of these gitaly-ruby processes is running this this thing with the dot in it. So that's the shim. Or if you had a shim, it's running that vendor executable. So that's how we got there. And this is very similar to what happens when you do a real push. I have a command here set up to do a real push on this same repo. Except I've made edits in the web editor, so I need to git pull first. Now this is what happens during a normal push. So that we're still under Gitaly, and there are these gitaly-ruby processes, but we're actually to the side of them, because here we have this git core hooks path. Well, that's just a config option, git-receive-pack process. So this is the thing accepting the git push, and that's the thing that then runs the pre-receive hook. So normally this is the job of git pre-receive, of git-receive-pack. It is git-receive-pack's job to run hooks around the transaction where the refs actually get updated. And the main thing I wanted to show today is, and maybe I'll get there very quickly. The main thing I want to show is how we simulate that behavior in the case of, okay, I'm a little distracted because one of my cats is very excited. So we're simulating this behavior in the case of things like commits in the web editor or merge commits, which behave the same from this point of view. So again, the difference is, so normally you would have git-receive-pack, and that then, okay, so gitaly git-receive-pack, and that then runs pre-receive, updates, post-receive. And in the case of web edits, okay, let me call this a normal push. Web commits, I guess. No, it's not a web commit. Commits created by GitLab on behalf of user. There we have the chain Gitaly. And this is the fact that this all hits gitaly-ruby is an implementation detail. It doesn't have to be like that, but that's how it worked out. And then gitaly-ruby is running these hooks. And what's interesting about this is that this is completely going through the back door, and there's no Git replication traffic of any sort going on here, because gitaly-ruby actually creates the commit directly in the repository as a Git object, and then it already exists. We just don't refer to it. So Git doesn't know it exists. And then by doing a ref update, we make Git aware of the existence of the new commits, and we simulate what would have happened during a real push. Is this making sense so far?
So when you say Git's not aware of it, you mean the executable was not invoked because we're using the Git library, what is it called?
Rugged.
Rugged. We're making a raw commit that doesn't have a ref pointing to it.
Yeah, actually, you can also do that with the Git executable. It's so this is more of a statement about how Git works as a database. So you have two separate databases in a Git repository: the object database and the ref database. And almost any transaction or any query in Git involves looking up the refs. So the ref database is much smaller, and Git will always try to load it into memory. That's a key value store that contains the names of your branches and your tags. And then everything in the ref database is supposed to point to a valid object, but Git does not go looking in its object database until you give it an object ID to look for. So on the one hand, so let me try to write that down.
So it's like a dangling commit because it doesn't have that ref.
Exactly, yeah, exactly. So what happens here is, and so in the Gitaly case, gitaly-ruby first creates dangling commit, then creates or updates a ref to, what do you call it, non-dangling?
Maybe an associated commit once it's got a ref that actually points to it.
I guess it's reachable is the word, to make the commit reachable.
Yeah, resolvable maybe, yeah.
I think reachable is the word that is used. Reachable, yeah, that's sort of like a graph theoretic word. So yeah, that's the process there, and this is quite different from a normal push, even though a normal push might create a reference for a commit that already exists on the server. So then you're also only doing a ref update. But in the typical case of a normal push, like what I'm doing here, when I do a git commit allow empty, this creates a new object that then doesn't exist yet on the server. So when I do this push, it actually has to send over exactly one object, which is just that commit, because that commit is new. So that's normally a git push is a combination of objects and ref updates. Without ref updates, there is nothing to push, and it's a no-op, so there's nothing. I wonder if the Git protocol lets you send git push without ref updates and just waste the server's time. Wouldn't be surprised if it lets you. But hopefully Git then never runs the hooks and just bails out the moment it realizes you're wasting its time. But I suspect that the ref updates, I'm not sure, but I suspect it might be at the end of the stream. And if it's at the end of the stream, then the server doesn't know that that the list of refs is empty until it reaches the end of the stream.
So it persists all the objects first, even though they're not really valid for that because there's no refs.
I am not entirely sure that that's how it works. Maybe we can look at that later if we have time. Because first I want to look at the where this stuff happens, because it's good to know where this is, and it's also it's legacy code where the organization just doesn't make a lot of sense. It's one of these things that somehow works and that we're a bit hesitant to touch. That is also, I mentioned that the fact that all these commits that GitLab creates on behalf of the user, the fact that happens in gitaly-ruby is because we have an existing ball of mud there that works, and we didn't want to duplicate that ball of mud on the other end. So we're sort of stuck with that part. There's another reason, which is maybe the more important reason, which is that some of that application some of that stuff that creates commits uses features of Rugged or libgit2, which is the underlying C library that we don't have in regular Git. So some of them would be hard to implement without libgit2, and because gitaly-ruby is currently the only place where we can use libgit2, some of these are stuck in gitaly-ruby for that reason. So now that I say this out loud, I think that's actually the real reason they're in there. But because of the, yeah, I'll show what it looks like in a minute, because it's just fairly complicated logic. To avoid the risk of having a duplicate implementation that behaves slightly differently, all these things are now concentrated there. So what does that look like, and where is this stuff? What would be a good RPC to look at? I guess we can just look at the web editor. The web editor uses an RPC that is called UserCommitFiles. And let's just double check that that is indeed in gitaly-ruby. That was too much test output, so grep outputs. I don't want to see test files. Okay, this is the definition of the function. And yeah, this thing is forwarding to Ruby. And it has to do some special stuff. It's a bidirectional stream. That's because this RPC can update an arbitrary number of files, and there is no limit on the size of the files that get updated. I think this is exposed to the API, so in principle, you could try to make an API call where you take a 1 GB binary file, encode it with base 64, put that in one post request. Good luck, but you could try that, and then GitLab will try to use this RPC to make a commit that creates that 1 GB file as a Git blob and then commits it. So to handle that, we use a stream RPC on a stream on the input, because we don't we can't put a sane upper bound on the size of the input. And I guess, yeah, this part close and receive, that means that the response is actually, sorry, response, yes. This means that the response is actually not a stream, so I was wrong. It's not a bidirectional stream, it's a stream going in, and it's a single response going back. It's just success or no success. Yeah, but the real work happens on the Ruby side, so let's go there. And there we should use, so the name is UserCommitFiles, but I need to use lowercase and underscores. And I'm lucky I get only one hit. This is the Ruby RPC handler for this RPC. So this is, you could say, the real RPC handler. And it's actually, oh, this is fun. So it has an actions array. And then this is a Ruby way to turn the stream into a Ruby enumerator. And I think it's actually just assembles everything. So if you would have sent a 1 GB base 64 request to one, if you would have used this RPC to say, I want to create a file with this 1 GB of binary data, then slowly in this, under this key, we're building up 1 GB plus the overhead of base 64 in memory of this gitaly-ruby process. This is also one of the reasons why gitaly-ruby is not so great with memory use.
So basically, if everyone's using the web IDE to update files at the same time, all those files are stored in memory in their entirety for all users.
Yeah, more than once, because well, it depends on the form. If they're using the web IDE, then it's text, and then we force it to be UTF-8. So I guess then we have only one copy, but I don't trust this code not to make a few copies along the way. So you have at least one copy of those files. And if it's binary, then you have the added cost of having an intermediate base 64 representation somewhere. I mean, in practice, you can't commit these really large files because you have to, there's a good chance, I don't know if we unpack them first on the Rails side, but these sort of crazy edge cases usually don't happen because you have to pass through Ruby Rails front end, and that thing will just choke or hit its timeouts before you can do these crazy things. But yeah, short answer, yes, it all gets loaded in memory. And if you're changing multiple files, which you can also do with, I think, with the web IDE now, because you can make a commit across multiple files. So that would then be one UserCommitFiles RPC call where we update all those files at the same time. Because of the way Git works, changing a single line means rewriting the whole file. So you're always sending the whole file down the line of the wire. Yeah, and then this thing uses something called repo multi-action. So that's where all the work happens. It also instantiates a user object, GitLab Git user, GitLab Git user, from data in the request. So this is a description of the user, and this is why commits in the web IDE actually get your name on it, or they don't. That's actually a good, just as an aside, good thing to look at. So these are my web commits from earlier. And if I do a very low level, take a very low level look with git cat file commit, then they are made by administrator admin@example.com, which is not very, which is obviously not me, or it's very different from this other one, because if I do the same with this, then they're made by my name and my email, because that's how I have my local Git client configured. But the reason this usually looks decent in GitLab is that you set up your username and your email on your GitLab user, and then we use those attributes in this application code that's further down here to fill in these fields. Yeah. So that goes into something called multi-action, and let's look for that.
Sorry, when you say it fills in the fields in the commit, you're only talking about through the web IDE, right? Because you can override that when you set your Git config, your local Git config.
Yes.
Right?
Well, if you're using local Git, then your local Git is creating the commit object, so it's using your local config. But the abnormal thing about features like the merge button and the web editor is that you're not creating the commit. You're clicking a button and GitLab is creating a commit, and GitLab is impersonating you, which is which is kind of what you expect. But if you think about it, it's also kind of weird. And this weirdness is amplified if you start thinking about signing commits, because GitLab can't sign your commits for you, because then GitLab would have to have your GPG key. So that's never going to happen. But when you look at the commit history of a project that's on GitLab, a bunch of those commits were really made by me running Git commands, and some of them were made by GitLab. And if somebody else had a GitLab instance, well, Git is so permissive, you can impersonate anyone you want. I guess that's the point.
I got it. So a potential future feature that might make like privacy-minded people or authenticity-minded people happy is if like GitLab has its own set of keys that sign on your behalf but aren't your keys, to show that this user was logged in and I have their key or something like that.
That's an interesting idea. Yeah. And I guess implicitly the promise of an app like GitLab is that GitLab's application logic will only let one user record exist with your name. So if GitLab made that merge commit, then and your username is on it, that means at that time there was only one user with that email, so to say, because that is a unique attribute. But when you think about it, that only says so much. Anyway, let's look at how this sausage is made. So wait, I was going to look for multi-action, because that was the next step. That is the function that actually writes this. So we're now in the GitLab Git repository class, which is where a lot of a lot of the application codes that used to live on the Rails side that did this stuff used to be in a class with this name, and we copied that code over, and we have a class with the exact same name in gitaly-ruby now. There is still a class called GitLab Git repository on the GitLab CE side, so you can get nice and confused by this. But that's actually, I can show that in a minute. No, I won't show that in a minute. Let's not make it more confusing than it has to be. So this is multi-action, and this goes into something called operation service. An operation service is a utility class that does some of the work around ref updates that impersonate a user. And this thing yields a start commit, which is the commit that the branch is currently at before you create the files. And that thing might be nil. But so that's what this check is for. And yeah, then we have another utility class called index, GitLab Git index, which knows what these actions are, and that thing will apply each of the actions. So the actions can be that you can change the contents of a file, you can change the name, you can change the file modes, or you can create a directory, or you can delete a file, things like that. You can bunch all of those together in one UserCommitFiles RPC, so you can have a sort of nice Git transaction where you can have you can make a bunch of changes to your repo with just one commit. And okay, so that is creating an index. Okay, so that's the index object, and that does write tree. So write tree actually gives us, this gives us a rugged object. And here we're going to create commit, which creates the dangling commit. This is a method further down. So that's literally just something rugged commit create. It's not clear what that means, but that's all it does. Let's go back to multi-action. So in the end, we just hand a bunch of parameters to rugged. But a lot of the work has already happened here, because this is the thing that created the commit references all the objects. If you are committing a new file, then that file has to be written into Git's object database as a blob. So that already happens here. So here, all those things get committed into Git, but they're dangling objects that are not commits. And then here, we take all the metadata to create a commit, which means a tree, message, parents, exactly what you expect in a commit. This is actually, if you compare this with what goes on in a commit, it's really literally the same. So this is a almost literal representation of a Git commit object. There's a tree, there's a parent, an author, a committer, and then everything after that is the message. That's what a commit is as far as Git is concerned. So that thing gets created here, and this yields the ID of that commit, and then we end up back, then we exit this do end block. Let me see if I can somehow, yeah. So that then we exit this block, and we end up back in this operation service thing, and that uses that commit ID to actually do the ref transaction. Still with me?
Just so I understand correctly, the index.apply, you said that that's only applying the objects, it's only persisting the objects, or it also did the commit?
This part does not yet create a commit. We only create a commit here.
Okay.
If you want, we can take a look at what this class does, just so that's demystified. And
also, just to clear things up, when we're creating the commit here, we still haven't specified a branch, like a ref that refers to that commit yet. We still haven't gotten to that point.
No, that happens here, actually. So this is the branch we want to start on. And so it's called operation service, but it really should be called ref updater on behalf of a user or something, because that's what it is. It takes a user and it's updating this branch.
Okay, so we have the branch within this closure, this function right now.
Yeah, yeah. Maybe looking at what this thing, how this thing creates the contents of the commit is not so interesting. I think it's better to first look at what this thing does, so we see how the ref transaction happens. So that is in this file. And let's see, where do we go? This thing takes a user and a repository. And then there's the with branch methods. So this is the, let's see, can we even this out a bit. So this is the preamble, and this is the thing that wraps. So this stuff in the middle, this creates a dangling commit, and this thing runs before and after because there is a do end. So this thing is responsible for the ref update. And the actual Ruby method we're looking at is with branch. So that is this one. So before we enter this do block, it does some work of its own. The moment it hands over control is the yield. So we should look for the yield keyword further down. Where's the yield? Actually, no, it takes a block and it hands the block further down. So this thing hands, okay, layers within layers. This is some bookkeeping. This is some fun stuff where it's actually allowed to call this RPC with a starting branch that is in a different repo. The use case for that is suppose that you want to make an edit to the README of GitLab CE, but you're not a member of the GitLab org organization, so you don't have write access on that repo. You can still click edit in the API, sorry, in the UI, and it will then on the fly create a fork for you and edit the file in your fork. And if necessary, it will fetch the file. I guess this isn't necessary if you already had a fork, but if your fork is behind, it will fetch the current version of the file into your fork and then you edit it there. So that's why we're interacting with a remote repository. Then we look up the start branch name and then we go into this thing. Oh, come on, clicked wrong. So I guess most of the work happens in this update branch with hooks thing. And with repo branch commits, well, I don't remember what that does. Let's just look at this one first. So where's update branch with hooks? Okay, this is not too big. This function ends down here. This is some config state that we're writing in the git config file. That's funny because we were talking about that the other day. Here's the yield. So this yield takes us into, actually, this yield takes us into this block. So we're not back at this code here that actually creates the commit, the dangling commit. But here we get this is a bit weird that it's called new rev, but this is really the commit ID of the new thing we're going to point to. And then we look up the branch and we do an update ref. We update the actual ref from the old value to the new value, and then we return the new value. So now the question is, do we look at what happens here, or or how we update the ref?
I'm kind of more curious how the ref is updated.
Okay, let's go there first. And that happens more than once. It's another, it's more indirection. Update ref with hooks uses the with hooks and then calls update ref. Let's see. So what does with hooks do? I think now we're getting somewhere. Oh, we're going to another class. Okay, so this goes into this class and there's a yield on that. Great. Do you want to see the update ref, or do you want to see how we run the hooks around the update ref? Over here, let's look at update ref, because that's
sure.
that's just this thing. So this is actually running git update -ref, and it's writing, it's using the standard in behavior where you can feed multiple ref updates. The main reason for that, I don't remember why we do it on standard in.
Because the parameters only allow just one new ref, right?
Yeah, because if we were using the argv, then you can pass strings via argv as well. So I'm not really sure. I don't really remember why we did it like this. Maybe we didn't want to leak the branch names, but that's not a very strong reason not to do it. Well, doesn't matter. It's git update ref. And that is a git plumbing command that modifies the ref database. And it does smart things like if you pass an old and a new value, then it will do an atomic transaction where it checks the old value. And if the old value has changed under your nose, then this thing fails. So this protects you against accidentally overwriting somebody else's commit that happened just before yours. So that's all that this is. So if we want to see how the hooks run, we now need to go to this file. Shall we go then that direction?
Sure, let's go down the rabbit hole.
Well, it's rabbit holes in every direction. The question is which rabbit hole. Let's see, hooks.service. And yeah, it keeps getting better because now we're in hook service. And this instantiates a GitLab Git hook object for each hook.
So hook object is just a reference to run the hook's executable, or what does that mean?
Yeah. Let me just pull up the file. So that's this one. This thing actually, so the weird thing is, so this thing says, I guess this is the orchestrator that says pre-receive and update happen prior to the transaction. So, and these are the ones that can fail the transaction. That was my trick earlier, where I put in a board in the hook file and then it bailed out. So this is where we're mimicking the logic of git-receive-pack in this hook service class.
Okay, so hook service is really a convenience for not having to know which pre-receive, post-receive, whatever hook.
Yeah, it just records the order of the hooks and their significance. Yeah. So yeah, this thing will return true or false. So if it fails, if the exit code is not 0, this returns false. And then this message gets wrapped in this exception and bubbles up the stack, and this actually gets passed back in the RPC response and then displayed in the UI. That was the red box I said, where I said, this is the hook you're looking for. That went through this exception mechanism. But if these both exit with 0, then this is true each time, and then we end this loop, and then we do a yield. So we yield control back, and then the ref update happens, and the ref update was up in this file. That's this guy. So this actually commits the ref updates to Git's ref database. And after that has happened, we end up back in this class and we run the post receive hook, which is when the which is what's supposed to happen. The post receive is there to have notifications and events happening after a ref changed. Yeah, so that's what this, I guess, yeah, that's the purpose. So these lines, this is the orchestration of how we run the hooks. Okay, we've accomplished something. We found something. We've got sort of come to the heart of this. Yeah, and this class here at the bottom, GitLab Git hook, is responsible for shelling out and running these things, feeding the arguments to the hooks that they expect and capturing the outputs, that sort of stuff. So this is just sub-process wrangling. So I guess it's not that, we can sort of ignore that. Unless you want to look at it.
No, that's okay.
Cool. Yeah, okay. So hook service, but hook service is hidden in, yeah, let me see if we can remember the layers. So UserCommitFiles is a Gitaly RPC proxied down to gitaly-ruby. Gitaly-ruby uses GitLab Git repository multi-action. Multi-action wraps, calls operation service. This is another one. We have operation service singular and we have operations service somewhere else. I never know which one we're in. I guess this one is singular. Calls operation service with branch and block, and then operation service with branch calls GitLab Git. Okay, this is also GitLab Git hooks plural. Yes, plural service, and the block. So hooks service takes care of pre-receive updates, post-receive logic, and yields to block in the middle. And multi-actions block is responsible for creating the dangling commit that will end up on the branch if all goes well. And that's not a given because you have features in GitLab where you can say that commit messages need to be validated. So it could be that this pre-receive hook looks at your commit message. So it could be that if I edit this file, if I now write a bad commit message, then this would go down the system all the way here until we create the dangling commit. And then the dangling commit, its ID gets presented by hook service to the pre-receive hook. And then the pre-receive hook makes an API call back to GitLab on the internal API. And then GitLab looks at that commit and says, well, I have a regex here and your commit message doesn't match the regex, so no. And then pre-receive returns with exit status 1, and the whole thing gets called off.
In between the pre-receive and the post-receive logic, is this also being quarantined in that alternate directory location?
No. So there's no quarantine here. These objects get written straight into the normal Git object database. And if this thing doesn't go through, they sit there until garbage collection. It's a good question. Maybe we should quarantine these, but that's not happening in this case.
And that's not the responsibility of the hooks. That's when you actually commit it, you have to configure it to commit it into the quarantine area.
Yeah, that would be if we were doing this, that would be the responsibility of multi-action. Because the way that works is we would have to instantiate. Shall we look a little bit at how multi-action creates this
Sure.
Git data in the object database? Yeah. So that uses the index class at first. And this thing uses a rugged, an object called rugged index. So repository.rugged, this is an instance of repository.rugged is a rugged repository. And when you instantiate rugged repository, you can tell it where its data directories are. So you can configure, if this thing was configured to write all new objects into a quarantine directory, then we would have emulated the quarantine mechanism. But it doesn't, and then we didn't. And then this raw index thing, we call write tree on it. A tree is the Git word for directory. And let's see if it's a blob. What a blob look like? I guess we can say rugged.write with a string and colon blob, and then it just writes it into the object database. So this is pretty much making direct rugged calls to create the Git objects. You want to, oh, and here you see the decoding, which is great. When writing to the repo. Oh, so if we're sort of wiggling in some auto line feed curlif mangling here. Lots of fun.
The base 64 is because this is coming from web requests originally, so it has to be encoded for JSON. Is that why it's in base 64?
It's on the this is exposed. The user commit files RPC is almost directly exposed via the public REST API, and that is a JSON API. So the first iteration of this thing only let you commit files with text UTF-8 text data. And then at some point somebody came in and said, hey, I want to commit binary stuff too. So then we added an option to, you have a flag on the API where you can say this is binary. Maybe I can show that for a moment.
Yeah, I was just wondering because Git doesn't really care that things are base 64 coded, right?
No. So this base 64, here it gets unwrapped. So there's there's a field somewhere where we say the encoding is base 64, and if that field is set, at this point, we decode. So prior to this line, content might be base 64 encoded binary data, but then we shadow the variable and we overwrite it with its decoded actual intended content. And then here we optionally mangle it for you, and then here we write binary data into Git. And if you want to see where this is, this would be in the Rails code base. This would be under lib API repository, I think. There's also documentation for this, but let's see if I search for encoding. No, that's not it. This is probably not the best way to look this up. CRUD for repository files. This is probably the thing that maps to user commit files. So that is a get. We don't care about the get. Get raw file, create new file. Data, branch, master, author, email, author name, content, some content. That maps quite closely to what we saw flying around there on the Gitaly side. And then here we have the optional encoding for base 64. Yeah. I suppose we could have, it would have been, maybe it would have been saner for us to do the base 64 decoding on the Rails side, but this is the sort of thing where we had a lot of code to migrate, so we have to make some decisions. So we exposed it on the RPC. Yeah, not sure if that was necessary in retrospect, but that's how it works now. So we're probably stuck with it. Yeah, so what have we seen? We've really, I said we were going to talk about merge commits. Now we're talking about multi-action user commit files, but the mechanics are really the same. To prove that, we can look at how the merge gets done. Merge. This thing, again, uses operation service and with branch. That's the same wrapper we saw before. And it does something. So what's special about merge is actually that we yield to commit ID all the way back to GitLab, and GitLab then commits it in SQL before the hooks run. This is kind of mind-bending. The reason this, before I'll go into this yield later. This yield is special about the merge. Here the commit ID comes back, this gets handed back to with branch, and then we go back into the ref update with the hooks around it, the same transaction stuff that I showed you. And create merge commits, this does some rugged magic, merge commits, and rugged creates a merge commit for us. So it really doesn't do that much. It doesn't do a lot of magic. But yeah, so okay, apart from this yield commit ID, are you with me so far?
Yeah, I guess wondering what happens if there's a conflict when you try to do that merge commit. Is that going to be handled here?
Yeah, good question. So merge index.conflicts, that happens here. So this thing returns a rugged object that has a Ruby method conflicts ? And if that thing is true, then there were conflicts, and then we return an empty return, which means in Ruby we return nil. So this thing can return nil, and so that was here. So this thing would be that's interesting. So this is a nil. Then we do a yield nil and we return nil. And I guess then this thing will raise that exception. And then we bubble nil up the stack again. But it's rugged. Rugged is the one doing the actual merge of the trees, which is a yeah, just looking at text files and history and trying to make the right decisions about what files should go where. All that logic sits there in Rugged. I think Rugged might have just borrowed it from Git because it's written in C. I don't remember if that's the case. And Rugged is also the thing that then can say, you know what, this is not working, there's a merge conflict. Because merge conflict is really just, if you look at how Git works, Git doesn't care about merge conflicts. Git just makes as trees and files and blobs and commits. And from a Git point of view, like if you just look at the database side, a merge commit is just a commit that has more than one parent. But from a user point of view, when we say merge, we mean they change some stuff, I change some stuff, go figure it out. And that part is actually, that is just a bunch of smart text manipulation that takes hints from the Git history structure. But Git allows you to create completely pathological merge commits. I could take two branches and create a merge commit where after the merge, there's zero data that was in either of the branches, but Git wouldn't see that or care. It would still be a merge commit. So the whole concept of conflicts is a function of the textual merge process. Cool?
Yeah, it makes sense.
Yeah. And you see the similarity with UserCommitFiles because we go into this same wrapper, and it's the same thing where here we create a dangling commit. This merge commit is dangling at first, and then at the end of this block, the dangling commit ID gets handed back up to this wrapper, and then this wrapper makes a commit on the target branch. That's why I was saying, well, we might as well look at UserCommitFiles. What's interesting about the merge RPC, now that we're looking at it, and the merge RPC is called UserMerge we tried to put the word user in all these RPCs because they create a commit on behalf of a user and they run hooks and all that. What's interesting about the merge commit is that there is a feature in GitLab where you can say, we have a branch, say the master branch, and we have a bunch of users who are allowed to update the master branch by clicking merge on a merge request, but they are not allowed to push directly to the master branch. This is a feature that GitLab hasn't had forever, but at some point, somebody came along and wanted this, and it makes some sense if you think about the merge request feature is about having a review process. And if you can just push straight to the master branch, you can bypass the review process. So this is the idea is that you can say as an organization, we don't want people to bypass the review process on this repo. There will be no pushes on the master branch. You have to use the merge function. So that makes sense as a feature, or like that makes sense why I would want that. But how do you build that? Because all our logic for blocking pushes goes through the hooks, and the hooks don't know if you're pushing. Actually, nowadays they do know if you're pushing from the from the command line over HTTP or SSH, or if it's through the web editor. But even then, you could be doing some funny things. And anyway, the way this feature got implemented is that during the merge, we create the merge commit, and then we know the commit ID. Then we yield the commit ID, and this actually then bubbles back up to the RPC handler, and the RPC handler sends a protobuf message back to the GitLab client. In the middle of the RPC, we send back one message with the commit ID, and then GitLab writes that commit ID in SQL as an attribute of the merge requests. And then that is the blessed commit ID that is allowed to finalize, to merge the merge commit. So when we return from this line, that commit is in SQL on the GitLab side. Now we yield it here, we bubble back up, and we end up in the pre-receive hook in the hook service class that I lost, but we end up in the pre-receive hook that makes an API call back to GitLab, and that API call includes the commit ID, and then GitLab says, well, here's somebody coming in, and this would close this merge request. Do you have the right commit ID? Are you the one we were talking to earlier? So it's sort of remembering states in the middle, and then the pre-receive hook can go through. This is a very subtle interaction, and we really only have it here in the merge RPC, and that's what this line is about.
So just to make sure I'm understanding this correctly, so when we're merging a commit for a merge request here, what we're saying is that the merge request was accepted, and now we want to merge it into the target branch.
Yeah.
Okay. And so we first notify Rails that here is the commit, and then when we get to the pre-receive hook?
Yeah, when we're in the ref transaction.
Okay, when we're in the pre-receive hook, it can refer to that that commit ID, which was already persisted in the database, and then allow it to proceed.
Yeah.
Okay.
And that's how GitLab can distinguish the case of, because normally, if you are allowed to push to the master branch, you can merge an open merge request by just doing a push on the master branch that happens to include the head of the merge requests as an ancestor. So if I have a, yeah, maybe it's the last thing I can just show that we're getting close to running out of time, but this is worth demonstrating. I'm going to push this on a different branch. This will create a merge commit, sorry, a merge request. It eventually. There we go. So this is now open. And if I go into the terminal, I can do a git pull, bad config line. Oh, great. That's, I'm editing the git modules file for fun, and it's completely broken now. So I should using a different example. And let's first delete this file. kind of typical that I like, let's edit a random file and choose one that can break Git. It's a bit malicious of me. Now I'm probably still in trouble. But I can do a git fetch. No. And now I can do git reset hard to this. And there is no longer a git.git modules. Okay, we're out of the woods. I'm going to just nuke the changelog then. Now if I do a fetch, my new branch will show up. It's already there. So now this branch exists, and there's my update changelog commit. And what I wanted to demonstrate is that now if I go to master and I merge that thing locally, so I just run git merge here on my terminal. And if I push this now, then if we're lucky, I don't have to hit refresh, but I'm not counting on it. You can see here the push got accepted.
Something's up with Zoom. Oh, there it goes.
And it was merged. So this is the thing that you can do, and that whole thing about yielding the commit ID back is about blocking, being able to block this, because in all other respects, this push I just did looks a whole lot like what would have happened internally with the RPC that creates a merge commit. But when I do this push, the database on the GitLab side does not know this commit ID and is not set to accept that commit ID.
So this is a toggle in the configuration for a repo?
Yeah, let's see if we can demonstrate.
So theoretically, you could use this to use a different merge request review application, right? Because you could just have a user that acts as a merge request app, for example, and then actually does the merge request and then pushes it to GitLab.
Yeah, but I'm not sure if you're using a separate app, then why you would open the merge requests in the web UI to begin with, because you.
Well, I mean, minus the web UI. If you didn't want to use the web UI, you could have an external app that just pushes as a user who has access rights to master.
Yeah. So the master branch is already protected, and we have these two different things: allowed to merge, allowed to push. So if I set this to no one, and now I do my trick again of creating a merge request, we should see it get blocked. Batch one, that's fine. It's very quiet on Zoom because I'm just staring and waiting. Okay, let's create the merge requests. So now patch 1 exists, and if I merge origin patch 1, and normally I would be able to push this, but this is now going to get blocked because I'm not allowed to push. You are not allowed to push code to protected branches on this project. But, and this is the whole point, I mean, this is the no, but there's still this yes. I can still do this, and this is still allowed. Except why is there a pipeline? Well, I hope this is...
Why is there no pipeline?
No, why is there a pipeline? Because this is a local instance and I don't have CI. So is this now going to hang until CI happens? Well, maybe, I don't know. Well, I thought we would be looking at more than just this topic, but I'm always wrong about that. So, but now we've seen, yeah, and we've seen this thing, and this is, to me, this is like, it feels like we now have covered the 3 different ways that data gets pushed into GitLab. There's SSH push, there's HTTP push, and then there is this behind the scenes thing where we create dangling commits and do our own little ref transaction in Ruby that runs the same hooks that would have been running during a real Git push. And yeah, I don't know yet what should be the next topic, but I feel like this is like a nice milestone for the training sessions that we've now reached this. Okay, time for me to see if I can turn off the recording again without fumbling. Bye, everyone.
Goodbye.